One of the biggest puzzles that a chemist has to solve sometimes is trying to figure out what something is. Like take this stuff for example. Is this water? I mean, it kind of looks like water. Ugh, doesn't smell like water though. Ugh. But how do you go about identifying something if it's not labeled and the molecules are too small to see? How do you do that? There are many tests that could be done to try to determine what a substance is. In the case of this substance, I know that this substance is a volatile liquid. A volatile liquid is something that easily evaporates under normal conditions, especially those below the boiling point of water. So I can make use of its tendency to easily evaporate to try to figure out the molar mass of this substance, which will help me identify the substance. I can do it right here in this lab, and in a few minutes, so can you. First, I want to get myself a flask, and the bigger the better, because the bigger the sample you have, the more easy it is to measure it and the less error we're going to have. I'm also going to get a boiling water bath going, big enough that the entire flask will be able to fit inside. Next, I'm going to take a small amount of my liquid and I'm going to pour it in. The exact amount doesn't matter, and at this point I don't even have to find the mass of it. Here's a pretty important part. I've got my flask with the volatile liquid in it and a piece of aluminum foil, and I'm going to cover the flask. But I need some of that volatile liquid to be able to escape, so I'm going to take a pin and I'm going to poke the tiniest hole I possibly can in the aluminum foil to allow those to escape, just super tiny. Oh, there we go, got it. Next, I'm gonna lower it into the water bath where the heat from the boiling water is gonna help my volatile liquid vaporize. And here's the tricky part. I gotta let it go until the liquid has just completely evaporated, but not any longer than that. And this is hard because the liquid is clear and it's inside a glass container, inside a clear liquid, inside another glass container, and it's really hard to see it sometimes. So I recommend giving it a little jiggle here and there. Oh, and when I see the jiggle, I can see my volatile liquid moving back in there. And I want to keep jiggling it occasionally until I stop seeing that little jiggle. All right, and now that my liquid has completely evaporated, I'm going to take it out and set it on the countertop to let it cool. At the moment I took it out, the vapor from my liquid was filling up this entire container. And as it's been cooling on the countertop, it has begun to condense a little bit, and I can see a little bit of liquid now at the bottom of my flask. Now to finish this up, we're gonna have to take some measurements on this liquid that remains inside the flask. The first is to take the mass of that liquid. The second is to verify the temperature of the boiling water bath, which should be close to 100, but it might not be. And we want to know that because that is the temperature of the vapor the moment I took it out of the water bath. Now we need to know the volume of the flask. It says 500, but there's all this space above there that the gas is filling up too, so we need to find the total volume of the flask. The easiest way to do that is to fill it up with water all the way to the top. Even make a little mess if you want. And then take this water and pour it into a very large graduated cylinder, which you can then use to measure the volume of the liquid that fits inside of the flask. The last thing we need to know about our vapor is the pressure of the vapor. And the nice thing is that since there's a hole in the aluminum foil, the pressure inside the flask is the same as the pressure outside the flask. And so if you have access to a barometer of any kind, you can very easily measure the pressure of the gas in the room as well as the vapor in the flask. So there you have it. With a few measurements from the lab and our good old friend, the ideal gas law, you'll be able to figure out the molar mass of your volatile liquid. Bye guys.